Hey everyone, it's Mrs. Slauson. So we are on page 48 in our spiral. This first video is going to be looking at section 2.6, and we're not going through this whole thing, but we're going to get the key ideas of it. So in 2.6, we're going to start to look at function operations, which means we're going to be looking at the 4 basic operations in math, adding, subtracting, multiplying, and dividing. And what we're going to do is we are going to be combining other functions or functions to make a new function. All right, and one thing we're going to keep in mind is our domain. If you remember, domain are those x values, and as we start to make new functions out of old functions, we just want to keep our domain in check. So domain again is x. If I were to evaluate these functions, would I be able to use every x possible? All right, so let's just go ahead and get right into it. Page 48. And we are going to start with our two functions. We've got f of x, which is x cubed. That's our cubic shape, and x squared, our quadratic, our parabola shape. And we're just going to perform the indicated operations, and then it says find their domains. And we'll talk about that in just a second. So the first thing we're going to do is let's just take a look at f of x and adding g of x. So f of x is x cubed. G of x is x squared, and what we should be doing is adding these. And although I would like to add these, I actually cannot add these any more than what they are. I can't combine a single term, because if you remember, adding, subtracting, I've said this before, is very picky. These would either have to both be x cubes or x squareds to simplify them down. So this is it. It's probably not the best example to start out with, but we have added them. And now what we're going to do is we're going to set this up as a subtraction problem. And then that's all we'll be able to do on this problem. Because for the same reason as addition, we can't subtract those because those are not like terms. Now when we get into our multiplying of them, multiplying turns out to be a little bit more forgiving. If you remember x cubed, this just means you're multiplying x 3 times. Here's this times sign. And then this x squared says I'm multiplying x 2 times. So when I'm done, I'm multiplying x 5 times, which the shortcut which you learned in Algebra 1 and in middle school, you can just add the exponents as long as those bases are the same. And then in the third one, we are going to divide them. So if you took x cubed, and I'm going to write it as a fraction over x squared, then this just means, again, multiplying x 3 times, multiplying x 2 times in the denominator. And what I can do is cancel out some of these x's here so that when I'm done, I get just a single x. So let's talk about the domain. We never really have to worry about domain at this point in Algebra 2 unless we are dividing our functions, because there is a possibility that when you have a fraction that your denominator might end up equaling 0. So here basically, if I wanted to put numbers in for x, I could pick at anything I want and cube it, square it, and then add those numbers up. And then the same thing here with subtraction. I could put any number in for x, cube it, or square it, subtract it, and it would work. Even here, I could take any number, cube it, square it, and then multiply those, and I would still get an answer. However, when I look here, because I have a denominator, one issue that appears with division is that your denominator cannot equal 0. So I always want to look at my function before I simplify it, because here, is there an x value that actually wouldn't work? And there is. I would not be able to put 0 in the denominator because I can't take something and divide by 0. So as far as my domain's going to be, I'm going to say that D for domain, that x cannot be 0. And that's the only time we're going to have to worry about domain for now, is when we have x and a denominator. All right, so let's move on. I want to skip this example for a moment and jump to page 49 and just try this one. So the first thing I'm going to do here is on g of x, I'm going to change that to a squared. And in my first function, this one's written a little differently. Now when we combine our functions, we're actually going to make this be a new function. Once we combine these two functions by subtracting, I'm going to call it h of x. So h of x will come by us taking g of x, which is 2x squared plus 3, and I'm going to wrap it in parentheses, and I'm going to subtract f of x, and I'm going to put that in parentheses as well. So one thing I like to do is to make this, which I think is a little simpler, going back to elementary school, when you would subtract, you wouldn't typically do this left to right. You would have stacked the problems one on top of the other. So it's 2x squared, and then underneath it, I'll subtract the x squared. And then with the 3, I'm going to leave an empty space here. You'll see in just a minute. There's a positive 3, so there's 2x squared plus 3. And then I'm going to subtract again. There's that x squared. Here's minus 4x. And then here's the 3 that they had. And I'm still going to keep the bottom part in parentheses like this. All right? So now when we subtract, we can see how this exactly will go. So I'm going to put a 1 here. And if I have 2x squared and I subtract 1x squared, that just becomes 1x squared. Now here I'm just going to put a placeholder of 0, or even better, 0x. And here I'm going to have 0x, and I'm going to subtract already this subtracted 4x. And remember, if you subtract with, we can view this as a negative. Cool. All right, I did pause through that announcement. Anyway, we're doing 0x, and we're subtracting and looking at this as a negative 4x. And when you have 0x and you subtract that negative 4x, remember, that's like adding a positive. So that's actually going to become a positive 4x, and then 3 take away 3 is 0. So when we're done, our new function, h of x, is going to equal 1x squared, or just x squared. And then that's a positive 4x, so I'll put 4x. Okay? Now what we're going to do is we're going to take our new function, which is h of negative 2, and we're going to evaluate it, which just means I'm going to go here to the right side where those x's are, put that negative 2 in, and when I do that, I'm going to use parentheses. Anytime I evaluate, put something in it, I'm going to wrap it in parentheses. And then I'm just going to follow my order of operations. So these parentheses are only there to hold the number, but what I'll do first is my exponent. Negative 2 squared is negative 2 times negative 2, so this term gets me to 4. And then when I multiply here in this term, I get negative 8. And then when I'm done adding them up, I get negative 4, and I'm going to write my answer as my function. When x is negative 2, gives me an answer of negative 4. So now what we're going to do is we're going to multiply the functions. So we're going to take f of x, again I'm going to put it in parentheses, and we're going to take it times g of x. And I want to remind you here that this is what I would call the neighbors meeting the neighbors. So the first neighbor that's going to go meet is x squared. And so x squared meets 2x squared, and we get 2x to the 4th. And then x squared is going to meet 3. And I'm anticipating an x cubed, so I'm going to leave a little placeholder there. And when I do x squared times 3, I'm going to get 3x squared. And now negative 4x is going to go meet everybody. So negative 4x meets 2x squared, and I get negative 8 and x cubed. And that's why I'm going to put that here, because I'm going to have my 4th powers lined up, my 3rds, and my 2nd powers. But now negative 4x is going to meet 3, and I get a negative 12x. With just a regular x, I don't really have a spot for it, so I'm going to put it here. And now the last person to go meet everybody is the 3, and 3 meets 2x squared, and I'm going to get 6x squared. So I'm going to start a new row for that, line it up with my x squareds, and then when 3 meets 3, I get a positive 9. Again, it doesn't have anything to line up with, so I'm just going to start it. So I'm kind of doing my own standard form here, the 4th power, my 3rds, my 2nds, my 1sts, and then no x's at all. And then I can just bring everything down. These will actually add up to 9x squared. And now I've done that. Now, it's domain. This is the first time, oh, and this one asked about the domain. So let's do this one, then we'll go back to domain. So again, domain is just, is there a number that I can't put in here? And it wouldn't work. So if I put it in there, I'd get an error message maybe on my calculator. And I can take any number and take it to a 4th, a 3rd, a 2nd power. So here there is no domain issue. So as far as the domain goes, when every number works, remember that all real numbers, that funky R, that's what we're going to do here. And again, no issues here. I can take any number and square it. I can take any number times 4. So as far as my domain goes here, it's just going to be all real numbers. The only time, again, we're going to have to worry about domain is if we had a division problem happening. And this was subtraction and this was multiplication, so we don't have that. All right, last thing on this one is we're going to evaluate the function. So I'm going to take -1 and put it into this function, and I'm going to take 2 and put it into this function and add them up. So when I take -1 and put it into f of x, I'm going to take -1 and square it, minus -4 with -1, and I'm going to add 3. And then when I take 2 and put it into g's function, I'll do 2 times 2 squared, and then I'll be adding 3. So following the order of operations, all the order of operations does is it gets each term, everything separated by an addition subtraction sign, down to one number. So -1 squared is 1. And then here you could look at this as -4 times 1, and all of that becomes a +4. And then when I put those together, I get 8. And then here, getting this term down to a number, I'll do my exponent first, that's 4, and then 4 times 2 is 8. And then I'll just add it with that 3. And so from there I get 11. And so now I can do that. I can say that f of -1 plus g of 2 ended up being worth 19. All right, last one I'm going to end with, we're not going to do the one on the bottom, is back on page 48, because they're just some different exponents again. So 4x cubed and 8x squared, I'm going to be making a new function h of x, and I'm going to get h of x by taking 4x cubed times 8x squared. And so what I like to do is just kind of separate this out. Like I'll multiply my, these are called the coefficients. I'm going to put my 4 and 8 together for 32, and I'm going to combine my x's together, and there's 3 x's multiplying and 2 more x's multiplying, so that's a total of 5 x's. And now I have my new function called h of x. All right, find the domain of h. Again, we are only going to worry about a domain when we are dividing our functions, which we are not doing, so I have no domain issues. My domain, we would just say all real numbers. And now what we're going to do is we're going to use this new function and put -1 in there. So we're using this function, and I'm just going to take 32, I'm going to put -1 to the 5th power. Without a calculator, I would do my exponent first, so -1 multiplied 5 times is still -1. And then when you take that with your 32, you get -32. And so the answer to our problem, I'm going to write it in purple all the way over here, our function h, when we make that x become -1, is -32. Now what we're going to do is make another function called k of x, and this time we're going to take g of x and divide it by f of x. So g of x is 8x squared divided by f of x, which is 4x cubed. And again, what I like to do is just kind of show you the long way of what's going to be happening here. So first, just 8 divided by 4, well, that's just 2. But then what's going to happen with these x's is these are going to cancel out so that we are just left with an x, but our x is actually in the denominator. And then this is our new function. This is k of x. Now the shortcut of doing this would be you still divide 8 by 4 for 2, but then you could subtract your exponents here. And then when you're trying to decide, if you take 3 minus 2 and get 1, where should that 1x go? Well, if you do the canceling out, you have more x's in the denominator, so that's where your extra x is going to go. Now here we do have a domain issue because we are dividing. And so I always want to go back to my original function, not the simplified one, but the original one, and just see what would my domain issue be. And the issue is going to be that this denominator, this 4x cubed, cannot equal 0. So what I'm going to do is just act like there is an equal sign and solve for x cubed. It's one type of x, so I'm going to divide by 4. And then to get rid of the cube, I'm going to cube root. And when you cube root 0, well, it's still 0. So here my domain, the x cannot be 0. And now finally, I'm going to evaluate k of 5 and k of 0. And if you notice already, this one, we just got done saying that you cannot put 0 into your function. So this one, where it says if possible, well, this one is not possible. Right away I know that because this said don't use 0. But I can put 5 in there, and when I do put 5 in there, I'm just going to go to my most simplified version, because that's going to be easiest to work with. And k of 5, If I put that into 2 over x, then k of 5 is just going to be 2/5, or if you want to put as a decimal, 0.4. And those are our notes for 2.6.